Hey guys, welcome to Step by Step Academy. My name is Akin. In today's video, you and me together we will learn about module arithmetic. Module arithmetic is the arithmetic of cyclic or periodic events. That is, events that have regular repeating pattern. Some like to refer to module arithmetic as the arithmetic of residues or arithmetic of remainders. And you will find out shortly why some people like to refer to it as the arithmetic of remainders or residues. Module arithmetic makes calculations involving cyclic events very easy. Examples of such cyclic events include the months of a year, the time of the day, and the days of the week. Now, the months of the year repeat itself after every 12 months. We go January, February, March, April, May, June, July, August, September, October, November, December. Then we're back to January again. So the months of the year repeat itself after every 12 months. So we can say that the month of the year operates in mode 12 because it repeats itself after every 12 months. Now, if we were to number the month of the year beginning from January, January will be 0. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if you take note here, the highest number that we have here is 11. This means that if I'm in mode 12, the highest number I will have is 11. So the highest number in any given mode is a unit less than the given mode. Similarly, if we consider the hour time of the day, which repeats itself after every 12 hours, so we can say that the hour time of the day operates in mode 12, while the minute hand of the day operates in mode 60, because the minute hand repeats itself after every 60 minutes. Now, if we number the hour hand of the day beginning from 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, you notice here that the highest number we have here is 11 because the hour hand operates in mode 12. 11 again is a unit less or 1 less than 12. Similarly, if we were to number for the minute hand, the highest number we have is going to be 59 minutes, which means that in mode 60, the minute hand, the number is 1 minute less than the mode. Similarly, if we consider the days of the week, which operate in mode 7, the days of the week repeat itself after every 7 days. So that means we can say it operates in mode 7. And if we number beginning from Sunday, 0, 1, 2, 3, 4, 5, 6. So we see here again that the highest number we have here is 6. 6 is 1 less than the mode. So what this implies is that for any given mode, the number must always be 1 less than the mode. In other words, we cannot have a number that is equal to the mode or a number that is greater than the mode. Now, suppose I have something like 31 mode 5. Now you can see 31 mode 5. Here 31 is greater than 5. So that means if I'm solving a particular problem and I arrive somewhere in the course of my solution, I cannot leave my answer like this because 31 mode 5 can still be simplified because 31 mode 5 is greater than 5. And to simplify this, we will do 31 divided by 5. 31 divided by 5 will give us 6 times, then remainder 1. This 1, which is the remainder or the residue, is our answer. So it means that 31 in mode 5 is the same thing as 1 mode 5. So this is why module arithmetic is referred to as the arithmetic of remainders or arithmetic of residues, because our answer is usually the remainder or the residue. In our next video, we will look at simplification of module arithmetic. Simplification of module arithmetic. Number 1. Suppose I am to simplify 76 mode 5. Now you can see that here the number we have here is greater than our mode. Therefore, we can simplify this expression. And to simplify, what do? We divide the number by the mode, 76 divided by 5. And we take note of the remainder, 76 divided by 5. So 5 in 7, that will be 1, remainder 2. 5 in 26, that will give us 5, remainder 1. So we have a final remainder of 1. This final remainder of 1 is my answer. Therefore, my answer is 1 mode 5. Number 2. Suppose I'm to simplify 340 mode 7. Again, I'm to check how many 7 can I get from 340. That's 340 divided by 7. 7 here is 1. 7 in 34. That will give us 4. 7 times 4 is 28. So we'll have a remainder of 6. 7 in 60. That will give us 8. 7 times 8 is 56. So we'll have a final remainder of 4. This final remainder again, or residue, is our answer. Therefore, 340 mode 7, when simplified, is the same as 4 mode 7. So this is how you simplify positive numbers in any given mode. Now suppose we have negative numbers. Let's say I have minus 42 mode 3. How do I simplify minus 42 mode 3? So what you do here is you look for multiples of 3 that is greater than 42. Multiples of 3 are 3 times 1, 3, 3 times 2, 6, 3 times 3 is 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 42, and then let's go 45. I can actually use 42, but let's use 45. So 45 here is going to, that means minus 42 mode in mode 3 can be written as 45 plus minus 42. 45 plus minus 42 mode 3. Now let's understand why do we need to add 45 to this, and does adding 45 to this, does it change the question? The answer is no. Now if you look at 45 in mode 3, if we consider 45 in mode 3, 45 in mode 3, when it is simplified, will give us 0 mode 3. Because 45 divided by 3, that will be 15, remainder 0. So this 0 is our answer. We have a remainder of 0. So adding 45 mode 3 to this expression is as if I'm adding 0 to this expression. And of course, you know, whenever you add 0 to anything, that thing remains unchanged. So adding 45 to minus 42 is like saying I'm adding 0 to minus 42. So nothing changes. But the reason why we're doing this is so that we can turn this minus 42 into a positive number. So 45 minus 42 mode 3 will give me 3 mode 3. And of course, 3 mode 3 means 3 divided by 3, which will give us 1 remainder 0. So this 0 again is our final answer. So my answer is 0 mode 3. And like I said earlier, I could have used this 42 as well. So if I use 42, so add 42 mode 3 to minus 42 mode 3 is as though you are adding 0. So if I add 42 mode 3, if you add that to minus 42 mode 3, so it's as if we're adding 0. 42 minus 42 plus times minus will give you minus here. So you have 42 minus 42 mod 3. So 42 minus 42 will give you 0 mod 3. So we arrive at the same answer. So any multiples of 3 that I use that is equal to or greater than 42 will give me the same answer. So this is how you turn a negative number into a positive number. Now, just in case you are still not clear, let's look at another example on how to change negative numbers into positive. Now let's take another example. Suppose I have minus 73 now in mode 6, and I'm to simplify this. So what I would do is to look for multiples of 6 that are equal to, or multiples of 6 that is equal to 73 or greater than 73. Of course, 6 times 12 will give us 72, but we need a multiple. 72 is not greater than 73 or equal to 73. We need a multiple of 6 that is either greater than. So let's do 6 times 13. That will give us 78. 6 times 13 is 78. Therefore, adding 78 to this expression is as if I'm adding 0, because 78 mod 6 is equal to 0. 78 divided by 6, that will give you 13 remainder 0. So adding 78 mod 6 to this expression is as if we're adding 0, so we're not changing anything. But the whole idea is to use the 78 to turn the negative 73 into a positive number. So if I do 78 minus 73 mod 6, therefore my answer is going to be 5 mod 6. So this would be my answer, because 5, the number I have here, is less than my mode. So this would be my final answer. This is how you simplify modular arithmetic in any given mode. Now, in this video, we will learn now how to add numbers in any given mode. So number 1, suppose I have 7 mod 3 plus 26 mod 3. Now if we are to add these two mode numbers together, now there are two ways we can do that. We can either add directly and then simplify, or we can first simplify the numbers individually before we add. So I prefer the second method. Let's simplify 7 mod 3. So if we simplify 7 mod 3, 7 divided by 3, that will give us 7 divided by 3, that will give us 2 remainder 1. So this 1 is our answer. So 7 mod 3 will be 1 mod 3. Similarly, if we simplify this, 26 mod 3, that will be 26 divided by 3, and that will give us 8 remainder 2. That will give us 8 remainder 2. So that means this 2 is our answer. So we're going to have 2 mod 3. Now we can add these two numbers together. So 1 mod 3 plus 2 mod 3, that will give us 3 mod 3. Now if you look at the number here is the same as our mode, therefore we can simplify further. So we do 3 divided by the mode, which is 3, and that will give us 1 remainder 0. So the 0 here, or the residue of 0, is our final answer. Therefore, this plus this is equal to 0 mod 3. Number 2. Again, suppose I have 51 mod 7 plus 29 mod 7. Now if I'm to add these two numbers together again, I can simplify 51 mod 7. So what is 59 divided by 7? That will give us 7 remainder 2. So this remainder of 2 is our answer. Therefore 51 mod 7 is 2 mod 7. Plus, similarly, I will simplify 29 mod 7, which is 29 divided by 7. That will give us 4 remainder 1. So 7 will go in 29 4 times. 7 times 4 is 28. 29 minus 28 will give us a remainder of 1. So we're going to have 1 mod 7. So now we have 2 mode 7 plus 1 mode 7. That will give us 3 mode 7. Therefore, our answer to this addition is 3 mode 7. Now, like I said earlier, you can choose to add the two numbers directly from here and then simplify. So if we choose to do it that way, we'll have 51 plus 29. 51 plus 29, that will give us 80. So if we choose to do it this second way, 51 mode 7 plus 29 mode 7, that will give us 80 mode 7. Now if you see, the number here is greater than our mode, therefore we have to simplify further. So 80 divided by 7. How many 7 can we get from? That will be 11. That's 77. So 77, that means there will be a final remainder of 3. So 7 will go in 80, 11 times, then remainder 3. Remainder 3. So our final answer is 3 mode 7. Just like we have using the first method. Now let's look at subtraction of numbers in any given mode. Number 1, suppose I have 21 mode 6 minus 7 mode 6. This is quite easy. Just do your normal subtraction. That's 21 minus 7 mode 6. So what's 21 minus 7? That will give us 14. 14 mode 6. 21 minus 7 will give us 14. But now if we look at 14 here is greater than our mode, so what we need to do, we can simplify this further by doing 14 divided by 6. So how many 6 can I get from 14? That's 2. Then there will be a remainder of 2. So this remainder of 2 is our answer. Therefore our final answer is 2 in mode 6. So the subtraction of these two values is 2 mode 6. Now suppose I have minus 31 mode 7 minus 2 mode 7. Now if we are to minus these two, we are going to have minus 33 mode 7. That's minus 31 minus 2. That will give us minus 33 mode 7. Now remember, we can't have a negative here. So what do? We have to turn this negative into a positive number. And how do we do that? By using multiples of 7 that are either equal to 33 or greater than 33. So let's check the multiples of 7. 7 times 4 is 28. 7 times 5 is 35. So 35 is a multiple of 7 that is greater than 33. Therefore, if we add 35 to this number, remember 35 mode 7 is equal to 0, because 35 divided 7 will give you 5 remainder 0. So the remainder 0 is our answer. So adding 35 mode 7 to this expression is as if I'm adding 0 to the expression. So I'm not changing the expression. So 35 mode 7 added to this expression. The whole idea is to use the 35 to turn this into a positive number. So minus 33 plus 35 will now give us 2 mode 7. 2 mode 7. Therefore, our final answer, since 2 is less than the mode, our final answer for these two subtraction is 2 mode 7. Another way to do this is to turn this into a positive number. So I can begin from here, turn this into a positive number. The first expression here can turn it into a positive number. So minus 31 mode 7. Let's look at, if you look at it from here, minus 31 mode 7. The closest multiple of 7 that is greater than 31 again is 35. So we can use 35 mode 7 to convert this into a positive number. And to do that, all we need to do is just add 35 minus 31 mode 7. So I'm just converting only this first expression. So this will give me 4 mode 7. So now that I've converted the first expression back now, I'm going to have 4 mod 7 minus 2, the second expression, which is 2 mod 7. So now if we minus the 2, we will end up having the same answer, which is 2 mod 7. So this is how you add and subtract negative numbers. In this video, now we will look at multiplication of numbers in any given mode. Suppose I have 2 mod 3 times 3 mod 3. It's the same thing as the normal multiplication. 2 mod 3 times 3 mod 3 will give us 6. So just multiply the two numbers. That will be 2 times 3. That's this 2 times this 3. Then mod 3. And that will give us 6 mod 3. Now what is 6 mod 3? If we simplify, 6 mod 3 can be simplified. If we simplify, 6 divided by 3, that will give us 2 remainder 0. The remainder again is our answer. Therefore our answer is 0 mod 3. Now number 2, suppose I have 4 mod 7 times 19 mod 7. Again, I can choose to do this directly by multiplying both numbers, or I can choose to first simplify 19 mod 7. So let's do it directly. So 4 times 19, then mod 7. So 4 times 19, that should give us 76. That will give us 76, then mod 7. Now from here, 76 is greater than our mod, so we will have to simplify this. So 76 divided by 7, that will give us 10 remainder 6. So again, this remainder of 6 is our answer. So we'll have 6 mod 7. Now, like I said earlier, we can also choose to do this by first simplifying 19 mod 7. So let's do this by first simplifying 19 mod 7 and see if we will have the same answer. Now simplify 19 mod 7. That will be 19 divided by 7, and that will give us 2 remainder 5. Now again, the remainder is our answer, so 5 mod 7 is the answer to 17 mod 9. Now we now have 4 mod 7 now times 5 mod 7. If we multiply the two, that's 4 times 5 mod 7. That will give us 20 mod 7. And now since the number here is greater than our mod, we have to simplify. So 20 mod 7 means 20 divided by 7. That will give us 2 remainder 6. That's 2. 7 will go in 22 times, remainder 6. Therefore our answer, the remainder, which is 6, is 6 mod 7. So again, you see we have the same answer as previously. So we have 6 mod 7, 6 mod 7. So this is how you multiply numbers in any given mode.